Hello and welcome to the second example in the study of Newton's law of gravitation. The link to our first example, I'll drop the link in the description of this video. So do well to check the description of this video. You see a link to our previous example in the study of Newton's law of gravitation. At this junction here, let's dive into the second example in the study of Newton's law of gravitation. Example 2, please. Two particles of masses 1 kilogram and 2 kilogram are placed at a separation of 50 centimeters. Calculate the force attracting between them. Find the initial acceleration of each particle, assuming only mutual gravitational force acts on them. First things first, in science, whenever you read the question, your first priority is to list out the given parameters, please. So what are you given? Actually, the question there. So given there, first things first, I'm given M1 as 1 kilogram, right? So 1 kilogram. M2 is of course 2 kilogram. Next up, the distance there, R, is given as what there? 50 centimeter. Go and check my initial classes from beginning, from gravitational field. We said out there is distance, we know, but it's not in centimeter, rather in what there? In meters. Convert that man to meter, that's tax. Convert this man to meter, please. It's easy as to convert centimeter to meter. It's easy as what there? Divided by what there? 1 by 100, that's all. So divide by 100, so 50 over 100, this gives about 0.5 meters. All right, I'm done with the conversion of my stuff here. So the one says, listen, it says that calculate the force of attraction between them, that's F. It's easy. I'm given M1, M2, I'm given R. It's easy. Apply what there? The formula for Newton's law of gravitation. So for me now, I have to recall the general form of Newton's law of gravitation. That's F is equal to capital G M1 M2 over R squared. Please plug in your values and that's all, please. From here, we say that F now should be equal to G. G is a constant, universal gravitational constant. That's what there? 6.67 times 10 to the power minus 11, that's G. M1, M2, M1 is 1, M2 is 2, as you can see clearly from here. All right, next up please. All over R squared. What's your R? It's easy. Don't give me 50 centimeter. Rather, give me the converted value, please. That's what there? 0.5. 0.5 what there? All squared, please. If I'm to punch correctly from here, I should have that my force F should be equal in value to 5.34, right, times 10 to the power minus 10. Please, what is my unit here? My unit is Newton. Why? It's force, please. Force. So here is what is Newton, please. I'm done with finding my force. By the way, that's not the end of the question. It says that find the it says that calculate the force attracting between them. That now says find the initial acceleration for each particle. Particle there, I mean the masses. For M1, for the particle 1, by particle, I mean masses. And I have two particles there. M1, M2, particle 1, particle 2. I'm asked to find the acceleration at particle 1, acceleration at what there, particle 2. It's easy. Let's get acceleration at particle 1. Particle 1, please. For my particle 1, please look up. For my particle 1, go back to Newton's second law of motion that says that F is equal to ma. So from here, I will know that F is equal to ma. I'm asked to find acceleration. It's easy as making acceleration subject of the what there of the formula F over m. Now, what's your F? Of course, F is constant. That's the value here. That's 5.34 times 10 to power minus 10 all over what is mass? The mass at particle 1, that's m1, please. So what's m1? That's 1. So that's 1. So any value divided by 1 is that value. So this divided by this of the cost. So acceleration at particle 1 is equal to 5.34 times 10 to power minus 10 meter per second square. This man is for acceleration, please. That acceleration at particle 1. Let's get acceleration at particle 2. For particle 2, it's as easy as your normal formula A equal to what there? F over m. In this case, what there? M2. So A should be equal to F is of course 5F is of course 5.34 times 10 to power minus 10 all over the mass 2. M2 is of course 2. Check there, M2 is 2. So the acceleration at particle 2 should be equal in expression as that's 2.67 times 10 to power minus 10, of course, meter per second squared. So this is how you solve this course particular question involved in the concept of Newton's law of universal Newton's law of gravitation. All right, as I solve this particular question, do well to like this video, share to your friends, and also subscribe to my channel. If you are interested in donating, right, no amount is small, right? We really appreciate your effort, right? So do well also to join my channel membership for the WAEC and JAMB classes. So have access to close to 250 plus tutorial video on mathematics, chemistry and physics and other science related courses. Visit my website at www.gravitation.com/courses. There in my website you get close to several science tutorial videos that you can actually purchase so you can learn. Once you purchase those courses, it's a lifetime access. Please do well to join our WhatsApp channel or WhatsApp group. I'll drop the link to the WhatsApp group in the description of this video. So check the description of this video. You see a link to the WhatsApp group there. You can join and then we'll learn together. All right, thank you for watching this tutorial video. Share to your families and friends. Very important, please. So do well to let us know which content you want us to create in next video. So let us know the video you want us to create in our next class. leave it in the comment section and I'll reply you as fast as I can. All right, see you in our next class.